6.05, solving quadratics. So we're going to be mixing back and forth between factoring and by completing a square. We're going to first start off by doing both, it's the same problem, and then we'll talk about why you might only use one of them. So solve by factoring, we are looking at our A and our C. So we get negative 16, and we're adding a negative 6. So we're at factors of 16, 1, 16, 2, 8. 3 doesn't go into it, 4 does 4 times. One of these will be negative and needs to add to negative 6. So negative 8 and positive 2. So we get our x minus 8, x plus 2. And that means that our intercepts are the additive inverses, so x equals 8 and negative 2. Let's do the same thing with completing the square. So first thing we're going to do here is move that 16 to the other side. So we add 16, we get 16 is equal to x squared minus 6x. To complete the square, we take this number, cut it in half, and square it. So negative 6 over 2 is 3. 3 squared is 9. Add 9 here. Add 9 there. 9 and 16 adds to 25. This we can write as a binomial squared, which is going to be x minus 3. Remember, it's always half that middle number. Squared. Then we're going to square root both sides. We get plus minus 5 is equal to x minus 3. Then we add 3. So we have 5 plus 3, which equals 8, and 5 minus 3, which equals 2. Negative 5 plus 3 equals negative 2. And those are the same answers that we have on the left side. How do we know when to use each method? Well, completing the square always works. Factoring, I think, is faster if it's easier, like if the numbers are easy to find. So if you can factor, I would factor, but sometimes you can't factor an equation or a quadratic, so you need to complete the square to factor it. That's basically the answer. Find the x-intercepts of each function. Use any method. Okay, so let's look at this first and see if we can factor it. First thing you want to do is pull out the 2. X squared plus 4x minus 21. So what multiplies a negative 21 and adds to 4? So 21. 1 and 21. 2 doesn't go into it. 3 does 7 times. 4 doesn't go into 21. 5 does not. And 6 does not. So we're trying to get to negative 21 and add to 4, which means that we are going to have a negative 3 and a positive 7. So we can factor x minus 3 times x plus 7. And that means that my x values are positive 3 and negative 7. So we factored, we're done. We found the x-intercepts of our model A. Model B, well, we're trying to get to negative 5. And the only factors are 1 and 5, and it needs to add to 10. Well, we can't add to 10 with 1 and 5. So we must complete the square. First thing we want to do, move this 5 to the other side, so we're going to add 5. So we get 5 is equal to x squared plus 10x. To complete the square, we take our 10, cut it in half, and square it. So 10 over 2 is 5. 5 squared is 25. So plus 25 and plus 25 over here. 25 plus 5 is 30. This as a binomial squared is x plus 5 squared. Now we're going to solve for x. Square root both sides. We get plus minus square root of 30 equals x plus 5. And then we're going to subtract 5 from both sides. So our answer is negative 5 plus minus square root of 30 equals x.